Hi folks, we're going to take a look at number 11 from page 74. So what they want us to do here is to find the equation of the line that's tangent to this function and is also parallel to this given line here. Okay, so there's a few things we're going to have to do in this question. So let's see if we can figure out, first of all, what we're looking for. So we're looking for the equation of a line, which of course means we need a slope and we need a point. Okay, so these are the two things we need in order to find the equation of a line. So let's start with the slope. Well, we know that the line we're looking for is parallel to this given line here. Okay, so if we find the slope of this line, we'll know the slope of the line we're looking for. All right, so let's just rearrange this to solve for y. So bring the 6y to the other side. So we have 6y is equal to x plus 4, and y is equal to 1/6. X plus 4 over 6 is 2/3. Although I don't care about the 2/3. This is what I'm looking for. So the slope that I'm going to use is 1/6. All right. Now the thing is we have to find a point. Well, what we know is that this line is tangent to the curve y equals x plus 1. Or root x plus 1. So if you think about what that looks something like that. There's probably only one, or it really looks like there's going to be only one point where the slope of the tangent is equal to 1/6, because it looks as though the slopes of the tangents are always different. Okay, so the idea is to find the derivative of this function and figure out when that derivative is going to be equal to 1/6, which means that the slope of the tangent is equal to 1/6. So that's our next step, is to figure out the derivative of this function. So the derivative of f, which we can use a notation we call f prime at x. This represents the derivative function of f, is equal to the limit as h approaches 0 of f at x plus h. So wherever I see x, I'm going to replace that by x plus h. So x plus h plus 1 minus f at x, which is root x plus 1 all over h. All right, we have to determine this limit. Now, because I'm going to want, hopefully at some point, a factor of h in the numerator, I need to get this h out of the square root. And the trick we use is to multiply numerator and denominator by the conjugate of this expression. So in other words, multiplied by root x plus h plus 1 plus root x plus 1. But of course, if I do that to the numerator, I've got to do the same thing to the denominator. So root x plus h plus 1 plus root x plus 1. All right. So let's simplify now. So here I've created a difference of squares. So the middle terms cancel out. So I'm just left with the first term squared, which is x plus h plus 1, minus the second term squared, which is x plus 1. And again, put everything in brackets, because here this subtraction will make a difference as to that numerator. And so the denominator we have h times and that conjugate. All right, so here, let's see if some nice stuff happens. So we see x minus x, nice, 1 minus 1, that goes. And so the only thing I'm left with in the numerator is h, which is what I needed, which reduces with the h in the denominator. Okay, so we're left with limit as h approaches 0. Okay, everything in the numerator either subtracted out or we were left with h over h. So I'm just left with 1 in the numerator, and in the denominator, I'm just left with this term here. So square root of x plus h plus 1, okay, plus square root of x plus 1. Okay, but now the denominator is no longer approaching 0, so I can finally evaluate this limit. So again, limit of the numerator, just a constant, it's 1. And here, this expression here, as h approaches 0, is just going to approach root x plus 1, plus this other root x plus 1. So I'm left with 1 over 2 root x plus 1. And so here's our derivative. Now, where this is going to be useful is I know that the derivative needs to be equal to 1/6, because the slope of my tangent line, okay, needs to be equal to 1/6. So let's figure out when this derivative is equal to 1 over 6. And here, let's just do some cross multiplying. So we have 2 square root of x plus 1 on the left, and multiply the 6 there. Divide both by 2. So I'm left with 3. And then finally, I can square both sides. So x plus 1 is equal to 9. And x is going to just be equal to 8. So I know this is the x value where the slope of the tangent to this curve is going to be equal to 1 over 6. Okay? But I need an actual point in order to find the equation of this line. So I just need to go and essentially input 8 into my function so I find the point at which this tangent lives, okay, because we know the tangent line and the curve are going to share that point. All right, so we can find the y value here by just inputting 8 into my function, and that's a nice one. That's 3. So now finally I can find the equation of my line. So y equals mx plus b. I know that the y value is 3. I know that the slope is 1 over 6. The x value is 8. And now I can just solve for b. So 3 is equal to, this just becomes 4 over 3. And now solve for b by bringing that to the other side and subtracting. Okay, so we've got 3, which is the same as 9 over 3, minus 4 over 3. And that's just equal to 5 over 3. And so finally, I've got my final answer. The line, which is tangent to the curve and parallel to that line that was given above, is just 1 over 6x plus 5 over 3. Okay, so this would be in slope-intercept form. If I wanted to change it to standard form, I could just multiply everything by 6. So we end up with 6y equals x plus 6 over 3 is 2. So 2 times 5 is 10. And then we just have x minus 6y plus 10 equals 0. Okay, although I'm perfectly happy to have it in slope-intercept form. All right, so just to recap, because there are quite a few things we have to do in this question. Step number 1 is to figure out what we needed. We needed a line that was parallel to this one here. That allowed us to find the slope. Okay, but we needed a point on this to find the equation of that line. So we used the fact that the line was tangent to root x plus 1. So we found the derivative and we determined that the derivative was equal to 1 over 6. In other words, the slope of the tangent was equal to 1 over 6 when x was equal to 8. From there, we were able to find the y value. And once we had the slope and a point on this line, we were then able to find the equation. Okay, that's it for this one.